Since the dawn of humanity, we have gazed up at the stars and wondered what lies beyond. Today, we stand on the edge of a new frontier: space colonization. As technology advances and private space companies like SpaceX, Blue Origin, and government agencies such as NASA ramp up their efforts, the dream of colonizing space is slowly becoming a reality. But what does space colonization entail? What are the possibilities and challenges we face? And how does the search for extraterrestrial life fit into this grand narrative? In this video, we'll take a deep dive into the future of space exploration. We'll explore the feasibility of colonizing planets like Mars, discuss the unique challenges of living in space, consider the potential for finding extraterrestrial life, and look at the broader possibilities of space as a future home for humanity. Let's get started by discussing what colonizing space really means. Space colonization refers to the idea of establishing permanent human settlements outside of Earth. For decades, the idea has captivated the imagination of scientists, writers, and futurists alike. Whether it's the Moon, Mars, or distant exoplanet, the allure of space colonization lies in the idea that humanity could one day thrive in worlds beyond our own. But before we can dream of building civilizations on distant planets, we must grapple with the practical and technological challenges that lie ahead. The first logical step in space colonization would be the Moon. With its close proximity to Earth, only 384,400 kilometers away, the Moon offers a relatively accessible location for building the first extraterrestrial base. NASA's Artemis program aims to land the first woman and the next man on the Moon by 2024, with a long-term goal of establishing a sustainable lunar base. The Moon could serve as a testbed for future missions to Mars, offering scientists the chance to study how humans could survive for extended periods in low-gravity environments. A lunar base would offer several advantages. First, the Moon's resources could be harvested for use in space exploration. For instance, the Moon contains water ice in permanently shadowed craters at its poles. This ice could be harvested to provide drinking water for astronauts and even be split into hydrogen and oxygen to create rocket fuel. Moreover, the Moon's low gravity makes it an ideal location for launching missions to other planets, as it requires less energy to escape its gravitational pull compared to Earth. However, living on the Moon comes with its own unique challenges. One major obstacle is the Moon's lack of atmosphere, which exposes the surface to harmful radiation from the Sun and space. To protect astronauts from radiation, lunar habitats would need to be built underground or shielded with thick layers of lunar soil, known as regolith. Additionally, the temperature on the Moon can vary drastically, ranging from -173 degrees Celsius at night to 127 degrees Celsius during the day. Developing technology that can regulate temperatures within habitats is critical to ensuring human survival on the lunar surface. The next big step in space colonization is Mars, often referred to as humanity's second home. Mars has long been a target for space exploration due to its similarities to Earth. It has seasons, polar ice caps, and evidence that liquid water once flowed on its surface. NASA, SpaceX, and other space agencies have set their sights on Mars as the next destination for human exploration, with Elon Musk's vision of building a self-sustaining city on Mars being one of the most ambitious goals. So, why Mars? First, Mars has a day length similar to Earth's 24/6 hours, which would make adjusting to the Martian day relatively easy for humans. The planet also has a thin atmosphere composed mostly of carbon dioxide, which can be used to produce oxygen through a process called electrolysis. While Mars' atmosphere is too thin to provide adequate protection from radiation, habitats could be built underground or shielded with Martian soil, similar to what is proposed for the Moon. One of the biggest challenges of colonizing Mars is its distance from Earth. At its closest, Mars is still 54.6 million kilometers away, meaning communication with Earth would have a delay of up to 24 minutes round trip. This distance also makes resupply missions difficult and expensive. For Mars colonization to be feasible, the settlement would need to be as self-sufficient as possible, with the ability to produce food, water, and other resources locally. food production on Mars presents a significant challenge. While Martian soil contains some nutrients, it is not naturally fertile enough to grow crops. Scientists are researching ways to modify Martian soil or use hydroponic systems to grow food in controlled environments. Moreover, water is crucial for sustaining life, and while there is evidence of frozen water on Mars, finding and extracting it in sufficient quantities will be a key challenge. In addition to the technological challenges of building habitats and producing food, there is also the issue of the psychological impact of long-term space travel and isolation. Astronauts on a mission to Mars would face months of isolation in a confined spacecraft, followed by years of living in a small, closed-off environment on a distant planet. The psychological toll of such isolation could be immense, and developing strategies to maintain mental health in space will be critical to the success of future missions. Beyond Mars, the next frontier in space colonization could be the asteroid belt. While not suitable for human settlement, asteroids contain vast amounts of valuable resources, including metals like iron, nickel, and platinum. Mining asteroids could provide the raw materials needed to build space habitats and spacecraft, reducing the need to launch materials from Earth. Companies like Planetary Resources and Deep Space Industries have already begun exploring the potential of asteroid mining, although the technology to mine asteroids on a large scale is still in its infancy. One concept that has gained traction in recent years is the idea of space habitats, large, rotating structures that could house thousands of people in space. These habitats, often referred to as O'Neill cylinders or space stations, would rotate to simulate gravity and could be placed in orbit around Earth, Mars, or other celestial bodies. Unlike planetary colonies, space habitats would not be limited by the conditions of a planet's surface, allowing for more control over the environment. The idea of space habitats raises fascinating possibilities for the future of humanity. If we can build self-sustaining habitats in space, we could potentially create new civilizations that are not bound to any particular planet. These habitats could serve as stepping stones for interstellar travel, with space colonies serving as waypoints for missions to distant star systems. As we explore the possibilities of space colonization, we must also consider the potential for encountering extraterrestrial life. For centuries, humans have speculated about the existence of life beyond Earth, and recent discoveries suggest that the possibility of finding extraterrestrial life is more likely than ever. In 2020, scientists discovered phosphine gas in the atmosphere of Venus, a potential indicator of microbial life. Meanwhile, NASA's Perseverance rover is currently searching for signs of ancient life on Mars. The discovery of life elsewhere in the solar system would be one of the most significant scientific breakthroughs in human history. It would raise profound questions about the nature of life, the potential for intelligent civilizations, and humanity's place in the universe. If microbial life exists on Mars, Europa, or Enceladus, it could provide clues about the origins of life on Earth and whether life is common or rare in the universe. The search for extraterrestrial life goes beyond our solar system. The discovery of thousands of exoplanet planets orbiting stars outside our solar system has opened up new possibilities for finding habitable worlds. Some exoplanet, like Proxima Centauri b, are located in the habitable zone of their star, where conditions might be right for liquid water and life to exist. In the coming decades, new telescopes and space missions will search for signs of life on these distant worlds. The possibility of intelligent extraterrestrial civilizations has long been a subject of fascination and debate. The Fermi paradox, named after physicist Enrico Fermi, asks a simple yet profound question: if intelligent life is common in the universe, why haven't we encountered it yet? There are many possible explanations for the Fermi paradox. One possibility is that intelligent civilizations are rare, and humanity is one of the few species to reach advanced technological development. Another possibility is that advanced civilizations are deliberately avoiding contact with us, or that they exist in forms that we cannot currently detect. The search for extraterrestrial intelligence SETI has been ongoing for decades, with scientists using radio telescopes to scan the skies for signals from alien civilizations. So far, no definitive signals have been detected, but the search continues. If we ever do make contact with an intelligent civilization, the implications would be profound. It could lead to a new era of scientific discovery, cultural exchange, and even interstellar diplomacy. However, the discovery of extraterrestrial life also raises ethical questions. If we find microbial life on Mars or Europa, should we attempt to preserve those environments, or should we continue with plans for human colonization? Moreover, if we ever make contact with an intelligent civilization, how should we interact with them? These are questions that humanity will need to grapple with as we venture further into the cosmos. In conclusion, the colonization of space presents both incredible opportunities and significant challenges. From establishing bases on the Moon and Mars to building space habitats and searching for extraterrestrial life, the future of space exploration is full of possibilities. As we continue to push the boundaries of science and technology, we may one day become a spacefaring civilization, with human settlements scattered across the solar system and beyond. The journey to the stars is just beginning, and the possibilities are as vast as the universe itself.